This conference will now be recorded.
Good morning, everybody. Hope I am audible to you.
Yeah, Tapan sir, audio is fine. You please proceed.
Okay.
Yeah.
So today we are going to talk about the IoT in the field of medical field. So when we talk about the IoT, till last 2 days, we already understand what is IoT exactly and how IoT can be implemented in different fields. So today we are going to talk about primarily the use of IoT in the field of medical. Now, where we can use the IoT in the field of medical. The first one is obvious. This is patient information management. Now, we can use, and we rather there are different type of device. Actually, it is a part of wireless sensor network. So it is a part of WSN only, and it is extended to IoT. Now, in case of patient information system, we can collect different vital information like the ECG information, ECG, EEG, then blood sugar, blood pressure, then even the mental health can be monitored. If we use EMG, EMG can be used to monitor the patient mental health. Then we can identify the nervous system, whether the person is nervous in a particular situation, and there are many things can be implemented and has been already implemented in many systems. Now all those information will be transferred to the server or a say big data center where data will be stored, and the analytical software can be analyzed different characteristic of the patient. One is the medical device and pharmaceutical anti-counterfeiting. So normally what happens, so when we use different type of equipments, there may be some counterfeit like medical devices. So actually, say a particular medical device is assigned to a specific location. Say for example, a device was allotted to an NGO, but that particular device is misused by the NGO and some other organization. It can be easily identified with the help of the IoT, where that particular system is currently installed, then whether it is working properly, who is using it, all those information can be identified. Similarly, in case of pharmaceuticals, so if there is any counterfeit of the medicine, if and it can be identified. Say if we are using or if we are having a very costly medicine, and if there is any chance of counterfeiting, so what we can do, we can use an RFID tag along with the medicine. So RFID tag is very cheap right now. Even we get the RFID tag in just 2 rupees. And as the cost is reduced to 2 rupees, we can use an RFID tag along with the medicine, so that if we want to find out whether that particular medicine is actually a genuine medicine or it is a counterfeit, it can be identified. The next one is the medical waste information management system. So as you know, in medical, we have different type of waste, and few waste are very dangerous for the human health or even living being health, like the used syringe, the needles, and there are few chemicals which is harmful for the living things. So using the RFID technology, we can actually monitor the movement of that medical waste, whether it is properly maintained or not, whether the medical waste is properly say disposed or not, and everything like how it is moving, the location and all. So if you use RFID tag with the GPS system with GSM communication, we can identify or find out all the vital information. And yesterday, one of the participants, she was talking about the fall detection system for the elderly people. And yes, this is a very important system for fall detection system for elderly people, because in many countries, even in India, along with the US, many people die every year due to the accidental fall of the elderly people. Because if a person is staying somewhere, he is alone. If he fall, no one is there to identify and take care of him. So this IoT can help there. If a person fall down, immediately those information will be transferred to the central server. Then it can be used the artificial intelligence or any kind of processing system to exactly check whether whatever information it is transmitting is correct or not. So because when you're talking about the fall detection, the position may be different. So today, as that young lady, she was talking about the fall detection system. So I'll try to demonstrate practically so how it can be done. So in today's session, we are going to use this fall detection system also in practical field. Then one is the drug store. Now, when we talk about the drug storage, so in hospital or healthcare system, it's very important to maintain the minimum storage or minimum stock of certain drugs. Now, how we can identify that the drug is available or not? If the drug is available somewhere where it is, the quantity and all, everything can be properly maintained or managed with the help of RFID tag. Actually, RFID tag is already used in many libraries. British libraries is one of the example where they are using the RFID tag to identify the book and the location itself. So similarly, the same technology can be used to maintain the uh, location and the availability of the drugs in hospital or medical. The one most important thing is the newborn anti-kidnapping system. So most of the time, when we say see a crime series or say a news, we come out with a message or news that a baby is say kidnapped or it was stolen. So it's a common issue in many general hospitals. So that's why if we can design a system which can protect the kidnapping or stolen of the baby, it will be definitely and one of the important system. So how we can actually use it? Now, if we use an ankle tag, so if we put an RFID tag on the ankle of the baby, at the same time, if we put another tag with the mother of the baby, they can synchronize and they can identify whether that particular baby is belong to that mother or not. So definitely, being a parent, we know okay, this is our baby. But what about in mass, in a large hospital? So here we can use this particular system, anti-kidnapping system. At the same time, if we use RFID in say gate, that means in a particular premises, if a baby is stolen from that particular area, immediately it should get the get activate the signal. Just like in many mall, we are having the RFID tag. So if a person exit the gate without billing, immediately it start beeping. So Obviously, if it is possible for the community, why not for the baby? So the same system can be used to protect the newborn anti-kidnapping system. One is the asthma monitoring system. So asthma, then depression, then Parkinson disease. There are few diseases that we have to take care of. One is the breast cancer also. In using the IoT, even it can help in breast cancer detection. So in case of patient information system, as you know, it's a very basic things like temperature, pressure, that is blood pressure, heartbeat, ECG, EMG, all those things can be connect or collect with the help of different sensor, and those sensor will connect with a central device. I'm not talking about the server, I'm talking about the central controlling unit. That this controlling unit will process or the bare minimum processing. It is not necessary that it will process the huge amount of data. The bare minimum data will be processed by the system and transmit to the main server, where we can use the artificial intelligence. And look, it might be boring for you. Okay, every time I am saying the same big data and artificial intelligence and transmitting data. So obviously, in fact, the system is based on these features only. The process is only that. Now, whatever you want to solve, any problem that you want to solve, you have to go through the same procedures. Only the thing is that your idea, what you want to do, what type of hardware device you have to use, how you have to process, that is the main thing. Otherwise, the architecture is always same. Then, in case of healthcare, so this is the symbolic diagram. So I have already shared this diagram yesterday. So we can use the temperature, we can use heartbeat, then transmit the data to again to the data center. Then it will communicate with the doctor. It can communicate with the attendant of the patient. Then if it is a minor, the information will goes to the parent, then the hospital authority, and even the health department can use all those data. Then when you talk about the identification of device, the RFID is widely used right now. RFID is not actually a very new concept. RFID is quite primitive, quite old concept, but it is widely using in many fields. Now, when you use RFID, simply it has one uh, RFID tag and one reader. Now, when you talk about the RFID, it's radio frequency identification device. Now, it will transmit the information to a specific distance only. It cannot transmit the information to a long distance. Now, there are different type of frequency, and depending on that frequency, we are having minimum 6 centimeter to 200-meter distance. Now, they are divided into LF, then UHF, then VHF. There are different type of RFID tag. So you can use the RFID in healthcare, manufacturing, inventory, shipping, retail, home, and many more. Now, when you use the RFID system, the first one is the antenna. This antenna is responsible to induce with the receiver. That means when we use RFID tag, the RFID tag is actually having an inbuilt antenna. Now, when you place the RFID tag near to a transceiver, that is the RFID reader, so they get induced each other, and RFID tag can be active as well as passive. In case of active RFID tag, they're having a power system. That means it has a battery backup and it is active. But when you talk about the passive, it does not have any power system or power source. So whenever we place the card near to the reader, it gets induced, and due to the electromagnetic force, the electricity is generated, and that electric power is used by the RFID card to activate the inbuilt chip and transmit the ID. Now there are different type of ID again. So we are having 4-bit ID, we are having 10-bit ID, we are having 12-bit ID. Now when you use 125 to 128K RFID card, they are normally having total 12 characters. That means whenever we place a card near to the reader, the card will transmit total 12 characters, that is 12 bytes. The first 10 bytes represent the identification, that is the unique ID of that card, and last two character or 2 bytes represent the checksum. That means whether data has been transmitted properly or not. So that's why whenever we have to read a card properly, always we have to read the 12 byte, where the first 10 byte will represent the actual identification number of the card. Now, a few things I'll skip because directly I'll try to implement it practically. So now, as I already specified, there are two type of RFID tag. One is active tag, one is passive tag. Definitely, we are having a third type of tag, which is called the semi-active or semi-passive tag. In active tag, we have a power supply. In passive tag, we do not have any power supply. But in case of semi-active or semi-passive, it is having a battery backup, but it does not start immediately. Whenever we place the card near to the reader will send a signal with the help of EMF, electromagnetic field, then only the battery will activate. So it will provide the long duration or long backup of the battery. And depending on the frequency, there are three main RFID frequency. It is known as LF, HF, and UHF. Low frequency, high frequency, and ultra high frequency. Now, when we use different type of frequency, it actually represents how far it can transmit or how far it can communicate with the RFID reader or writer, and what is the speed of data communication. Then the microwave RFID can be transmitted up to 20 meters to 200 meters. It depends. We can adjust when you use microwave RFID. We can adjust the frequency and we can adjust the active distance. Now, in case of low frequency, it works from 30 kilohertz to 500 kilohertz. Though we use 30 to 500 kilohertz, that is, it is a recommended range of frequency, but normally we use 125 kilohertz. Now you might be already using RFID card. So in many educational institutions, they are having an RFID card to maintain the attendance. The same card can be used in a library or to access different resources in an organization. Those cards are primarily 125 kilohertz. But when you use 125 kilohertz, primarily they are not having the writing facility. Now remember, now what is writing facility? Now when you use RFID card, again, there are two type of card. One is only ROM, read-only memory. That means every card is having an unique identification number. and that number can be transmitted. That means that card will transmit only that identification number only. It cannot get any information, neither it can transmit any other information. But when you use a read-write card, it is actually called smart card or contact-less smart card. Previously, we had contact-based smart card, but right now we are not using contact-based smart card. Rather, we use contact-less smart card. Now, when you use contact-less smart card, it is having a storage area. Minimum, we have 1K of storage area in each card. Now, how it can be used? Now, we can store the primitive information like the name of the person, then branch or a department, then a date of birth, a blood group. Many information can be stored. In fact, the driving license that we are using, we are having, they are actually type of smart card. It may be contact based and contactless. So we are using those cards. Unfortunately, there are only few cities or state who are actually using the facility of that RFID or smart card. Like in West Bengal, in Assam, in even in Maharashtra, we are not using the smart card properly. We are having that driving license. We are having that driving license card, but it is not storing any vital information. But yes, in Bangalore, they are using it. So the technology is not that tough, but still people are not using. It's a very interesting thing because either lack of the manpower. This is one more issue in India, though we call the India is superpower in software industry, but we are lacking behind the technology. So only coding, only software will not do, because no, even we talk about the economy in terms of the technology. So we are not having any specific hardware. We are using different type of software. We are using different algorithm. But thing is that the PC that we are using not made in India. So similarly, we are not having any good software which is produced by India, which can be used in artificial intelligence. So that's why it is very interesting that we are actually having lack of manpower, or rather we can say lack of technical or skilled manpower in the field of technology. Then when you talk about the high frequency RFID, so the range is 3 megahertz to 30 megahertz, and it can transmit up to few inch to several feet. So this type of card is primarily used right now. Actually, we have designed some system, so it is using in three Delhi public school in Assam. So we have designed the system to identify the student where they are. Actually, what happened? So they were using RFID card, but it was very difficult to identify the location of the student. What happened? According to a particular school authority, they told us that, say, they entered into the school premises, but after that we do not have any tracking system. So many students come to the school, and then most of the time they waste their time in washroom by playing game and all. So it was a major issue for that particular school. So they asked me what to do. So then we have designed that system through which they can actually identify where that particular student is. So here we are using actually UHF, not VHF, we are using EHF. Now when we use UHF, so it works in 300 to 960 megahertz, but normally we use 433 megahertz, because when we use 433 megahertz, it has low noise and it can transmit up to 25 plus fit. So it depends on you how you want to use the same system that I have already specified. If we can track the position of a student in a college or school, definitely we can track the position of a newborn baby in a hospital. Then, as I already told you, microwave can transmit up to 30 feet. Now, say medical device, pharmaceutical anti-counterfeiting, I have already discussed. So I have already shared the PPT. So you can download it and you can go through medical waste and all. Then a fall detection system. Now, what we can do to identify or implement the fall detection system, either we can use a simple tilt sensor, which is not that effective, but the most effective technique will be a three-dimensional or three-axis to six-axis gyroscope. So we are having different type of axis, three-axis to six-axis. So when you use only the accelerometer, it has only three axes. But if I use, or if we use gyroscope like MPU 6050, 6050, it is having six dimension. And today we are going to use the MPU 6050, for which we can check whether the person is standing or bending backward or forward, or whether he is fall down. Okay, now here we're going to use MPU 6050. Now this is the connection, and here we have to use I2C communication. So I have given a little bit about the I2C communication in last session PPT, or you can go to the internet and check for the I2C protocol. It is very interesting protocol. It was designed by Philips. It was designed by Philips, and every I2C device is having an unique ID. And till date, the NXP or the Philips. So NXP is nothing but the semiconductor division of Philips. So NXP is the authorized company who provide the addresses to each and every I2C device. So if we have to devise one I2C, say transducer or I2C device, we have to take the address of that particular I2C from the Philips. Now, when you use I2C protocol, so there are different type of serial communication, I2C, SPI, then we are having USB, RS232, RS45, RJ45. There are different type of communication protocol. Now, every protocol is having their own advantages and limitations. Now, when you talk about the I2C communication, it is inter-integrated circuit communication. That means two devices are used to communicate, but very
Sir, no audio, sir.
when we use I2C protocol, it is having two wire. Only two wire is used to communicate or establish communication between the host and the device. So here we have only one SDA, means serial data, and one is SCL, serial clock. Now, as the I2C protocol is a synchronous communication, that means the device, that means the receiver, this one, MPU 65, it is not having its own clock source. So in case of synchronous communication, the master is responsible. Here, the node MCU is the master and MPU 6050 is the slave. So in case of I2C communication, the master is responsible for providing the clock source to the slave. So why it's called slave? Because without the master, it can do nothing. But in case of master, it is independent. So when we use, say, RS232 protocol, they're asynchronous. That means both the transmitter and receiver, they are having their own clock source. Okay, anyway. Now when you say SCL and SDA, but when we use SCL and SDA, only two pins are used. But similarly, we can connect multiple devices from the same two wire. So here we are using only one device. But if you want to device multiple, say I2C device, it can be connected with the D1 and D2 pin parallelly. How we have to activate? The master is responsible for providing the signal to the specific device that I need information from you. So master will activate or initiate. And in that case, the master has to have the knowledge of the address of each and every slave. Okay, now I'm going to demonstrate the coding in fault detection. But before that, if we have to use MPU 6050, we have to install the library. Now, obviously the same process, go to Sketch, then include library, then manage libraries. And in the search bar, we have to write MPU 6050. And remember, the internet is sometimes full of garbage. So when we have number of resources, there are garbage also. So you have to find out which component or which software is actually suitable for you and which is not. So when you write MPU 6050, it will give number of lists, but you should go with Adafruit because Adafruit is well-known organization. So they maintain the rules and regulations. So that's why you should select the first one, this one. Just find out Adafruit and then. So here I am showing here version 2.0.0, but it is not necessary. Always try to use the latest one. I'm using here, it is already showing the install version is 2.0.1. So always install the latest one. Now here, I'm going to use the system, the fault detection. Okay, for that I have already given you the coding and all. So I'm just going to burn it and show you how it will work. So when we have to upload, first we have to select the board. My board is already selected. This is board not MCU ESP12E. And then we have to select the serial port. my port is connected to COM6, and then upload. Well, so what it is saying, Adafruit MPU 6050 has no such file or directory. So what we have to do? Tools, sketch, include library, manage library. It will collect the information. Then you have to write MPU 6050. And then select Adafruit, the first one, and install. Okay, done. Now, again, I'm trying to upload it. Error compiling for the board node MCU this. Now the problem is in this include file. Just a minute, let me check why it is giving the problem. Okay, it is saying that Adafruit bus register is not there. So include library, then again manage library. So when you use Adafruit libraries, it needs certain pre-installed libraries too. Say, let me check whether this library is installed in my PC or not. Arduino, then libraries. Oh, okay, it is already there. Adafruit sensor master is needed, so it is already there, but still it is giving problem. Let me check. Okay. So I have tested all those code in a different PC actually. Okay, I'll check it later. Just a minute. Let me discuss the DS18B20 then. Okay. Now, say when we have to use temperature sensor, so we are having different type of sensor like LM35, DS18B20, DS1620, this is 1621. But if we have to find out the temperature of a human body or the temperature of an animal body, we must have to use DS18B20. Now why? Because DS18B20 is actually having a probe type of structure. So it can be used as a probe and it is waterproof. So that's why you can go with DS18B20 waterproof. We are having two versions of DS18B20. One is raw. If you see the image, so we are having two type of DS18B20. One is just like a transistor, one is probe. So here we are going to use the probe one. Now DS18B20 is having certain features. The first feature is unique one-wire communication. That means, say, when you talk about the communication, so in case of parallel communication, we need minimum 8 wires, and including the ground, it will be 9. In case of, say, UART, we'll be needing 3 wire. In case of, say, SPI protocol, we need MISO, MOSI, CLK, and RST, 4 wire. In case of, say, I2C protocol, we need 2 wire. And here, DS18B20 work in 1 wire. Just 1 wire is needed to connect with the microcontroller or microprocessor. Then it has a 64-bit serial code stored. Now, what it is exactly? Now, DS18B20 is a smart sensor, unlike LM35. So when you talk about the temperature sensor LM35, and why I am repeating the same thing, LM35 and DS18B20, because most of the time in academic, people use LM35. But LM35 is a very cheap, cost-wise, is a very cheap transistor type sensor. It can be used for the small applications, but not for the sensor network. Now, when we use LM35, it is not having any address. Simply it gives the voltage to represent the temperature. But DS18B20 is having, every DS18B20 is having unique 64-bit serial code. That means if I purchase, say, 100 DS18B20, each and every DS18B20 will be having different address. So that's why it can be easily connect with a sensor network, because the sensor itself is responsible to provide self-identification. The next one is the multi-drop. Multi-drop means when you use, say, a sensor, say if I have to use, say, 3 LM30, say 3 LM35, okay. That means I will be needing 3 IO port of the microcontroller, that is 3 ADC. But when you use DS18B20, a single wire can be used to connect with multiple DS18B20. So this is very interesting and very important when you create sensor network. Next point is required no external component. That means directly we can connect DS18B20 to the microcontroller or microprocessor. We can program it, then we can remove it. After removal, actually you can program the high cut, low cut. The one sensor can be used without any other host. Next one is the power supply range. So it can work from 3 volt to 5.5 volt. So that's why, so it is suitable to work with, say, different type of microcontroller, Arduino, 8051, PIC, Avier, as well as Node MCU. Because in case of Node MCU, we are having the stable power supply of 3.3 volt. And it is working from 3 volt to 5.5 volt. Then when we select sensor, so any type of sensor, you must have to identify the working range, because depending on your requirement, you have to select the sensor whether it will fall under that particular range or not. Now here, we are using DS18B20 because it can measure from minus 55 degrees centigrade to plus 125 degrees centigrade, which is enough to represent the temperature of a human body, because it can goes up to 257 degrees Fahrenheit. So human body maximum it will goes to 108 in general case, 108 degree Fahrenheit. So we can use DS1820 very easily. Now accuracy is 0.5. That means if the temperature sensor is giving some fluctuating value, it will not give more than 0.5 degrees centigrade, and it is stable up to 85 degrees centigrade. But if the temperature goes, though it is recommended 85 degree, we have checked that when the temperature goes beyond 100 degree, beyond 100 degrees centigrade, then only it will give certain malfunctioning. It gives some wrong result. Then when you talk about the resolution, so it represents the accuracy of the data. So it is programmable. So we can program DS1820 to work with either 9-bit or 12-bit. Then conversion time is just 750 microsecond. That means it can immediately convert the analog temperature into digital form just within 750 millisecond. So as I already specified, this is one-wire communication. Only one wire will be needed. So only one wire is needed. This is called one wire bus. And multi-drop means the single wire. We can use only one I/O pin of the microcontroller where we can connect multiple DS1820. This is called multi-drop. Apart from that, it is having one more feature called parasite power supply. So I have shared the datasheet of DS1820 to you. Just read the dataset, you'll find that DS1820 is having number of interesting features. Now, normally when we use any electronic device, it needs power supply. But DS1820 can use the power supply from that IO pin itself. That's why it's called parasite power supply. It will draw the power supply from the IO pin of the microcontroller itself. Now, when we use DS1820, we are having number of commands. So that is one more headache, because in case of LM35, directly it will give the temperature and you have to convert it. Sorry, voltage, and you have to convert it into temperature. But here we have a list of commands. Then it is divided into two command set, roam command and function commands. The search roam is 0xF0. All commands are in hex, so we have to write 0xF0. That means if you have to search a particular room, that means if you have connect multiple DS1820 with the IO pin, first we have to find out. Then read from ROM. If you have to read the ROM address, 33H. If you have to compare the address, 55H. If you are using only one sensor, say we are using only one DS1820, then we don't have to find out the address and all. Directly connected. So we can use skip ROM. We can use alarm search, that is high cut, low cut. Then we have the convert. Now when you use convert, by mistake 1T is extra here. When you use convert, actually we have to give a command 44H 0x44. So the microcontroller will send 0x44 to DS1820, then it will start converting the analog data into digital form. Then that information has to write in scratchpad. After conversion, it will write in scratchpad. And scratchpad is nothing but internal storage in the DS1820 itself. Then if you have to read the information, we have to use the read scratchpad command. Okay. Then power supply, you can check whether the power supply is the external or parasite. So similarly, to install DS18B20, we have to go to Sketch, include library, then manage library. Then you have to write DS18B20. Then you have to select the version. So I have already installed 3.8.0 in my another PC. Then install it. But after installation DS18B20, we must have to install one wire library also. So next go to one wire library and install it. This is the circuit diagram for DS18B20 interfacing with Node MCU. So if I try to compile it, it will give error if I have not installed. Yes, it is saying Dallas temperature, no such file. So go to again Sketch, include library manager, then DS18B20. So here we have Dallas temperature. Version 3, then install. Okay. Then again, next I have to install one wire library. One wire. Then for the one wire, go to again Adafruit one that max 31850. Okay. Now again, I'm going to compile it. So compiling sketch, uploading. Yeah, it is saying uploading done. I will go to serial monitor. Now it look, it is showing 26 degrees centigrade. That is 79.70 Fahrenheit. Now, if I hold this sensor, This is the sensor. DS18020. Now if I hold it, so it will. Now look, it is increased to 31 right now. That is 87. So obviously, when we use the temperature, minimum we have to hold this temperature sensor for 1 minute. Then only it will give the accurate value. Okay. Now, this was the system I was supposed to demonstrate. I'll do one thing. I'll try to demonstrate during the next session if it is possible to manage the things. It is giving problem with MPU 6050. And this is the connection. So we'll use MPU 6050 and the DS18020. This system will identify or collect the information from the person, that is whether he is sitting or say standing, and the temperature. Even you can display the heartbeat of that person. So I have given the coding. You can check the coding itself. Then I had already discussed about the newborn things. So this was the end of this session. Actually, what happened? So by mistaken, I thought that my session will be start from 10 o'clock, 10 to 11. So that's why I have prepared less number of slides. So in the morning itself, just before at 9:25 only, I come to know that my hello. Hello.
Yes, sir.
Yeah, so due to the mistake, I have to stop the session right now.
Okay.
Okay, but the problem that I am facing with the MPU 6050, during next session, I will try to solve it. Okay.
Okay, fine, sir. Fine, sir. No problem.
Okay, fine.
So one more, is it questions are opened or you have to discard right now?
No. If there is if there any question, it's okay. I'm ready.
Okay, sir. Fine, sir. Then we'll wait for 2 minutes
Yeah.
because the session time is supposed to end by 11 o'clock. So we are getting end before this one. 15 minutes.
Yeah.
No problem.
If there any question is there or any discussion, yes, most welcome.
Chat box. Sir, you please check your chat box. There are some questions are there.
Actually, I'm not used to it. This one, I'm used to it Zoom. So
No issue, no
where
issue.
is?
I'll just tell you the questions. I'll just read out the questions for you. So the very first question is what are the frequency ranges that doesn't require license?
This is actually assigned band. That is 2.4 gigahertz up to 2.4 gigahertz. We do not need any license.
Yeah, yes. It is free to use. This Wi-Fi
Yeah.
frequency of 2.4 and 5.
Yeah. Right.
And RF
So
frequencies is not required to use.
you don't have to need any license for the RF frequency. So this is actually SM band. So I'm going to discuss the SM band during the next session. Actually, where
Okay.
we have to discuss about the Zigbee and Bluetooth and Z-Wave.
Yeah. I
So
think next session by this one, the afternoon session we'll be discussing about that. So I think there we can use it.
Okay. So any other
And one more
question?
question is that thanks for incitement, and what is the sensor used to identify bacteria and water?
Breast cancer,
Identify?
sir.
No,
Oh,
madam.
no, no, no.
This is posted by Shakila G. What is the sensor used to identify bacteria in water?
A
That question is
bacteria in
there.
water. Oh, yeah. So to identify the bacteria in water, we do not have any specific kind of sensor. So it is actually, we have to find out the chemical characteristic of the water with the help of el- electric characteristic or electrical characteristic of the water.
Yes, I think for bacteria we don't have any this one like that. I think
No, we don't have any inbuilt or ready-made sensor for the bacteria in the market till now,
yes, yes,
because
yes.
depending on different bacteria, the electrical characteristic will be different for the water.
Correct. We have water purity tester, but I don't think so. We have a bacteria tester, I guess.
No, we do not have bacteria. Water purity means actually what happens when we have to purify the water.
Yes.
So nowadays we are using RO and the
Hello,
so
Tapan
when
sir.
you use UV, it actually
Yeah.
kill almost it almost kill 90% of the bacteria, but
Yes,
it
yes, yes.
cannot detect bacteria. It will kill
No,
bacteria.
that's what. That's what. We don't have any sensor to detect bacteria or virus. Those are can be tested or identified under lab circumstances only. I think medical people might have
Right,
know better on this part,
right,
because you need
right,
to
right.
have a microscopic or electron or whatever microscopic is required.
Uh, yeah, right.
Yeah. And one more question is that how to use how to detect breast cancer. This one, sir. One madam posted regarding
You
this one.
Yeah,
using
actually,
RFID.
no.
RFID.
Using
RFID we can use.
RFID, RFID you cannot detect the breast cancer.
Madam,
Okay.
RFID, I can explain you RFID. RFID is something like a chip which will keep on emitting some data. Okay, like say
Okay.
banking
Identification,
item, asset
radio.
management, asset movement. With that, you can say like your ID card. You can place an
Yes.
RFID on your ID card. Okay, so
Okay.
that when you have an access, it emits some data and you can get capture of that RFID. That's it. RFID
Sir,
doesn't
yeah.
use.
In this session, sir has
Yes,
mentioned that breast cancer can be detected by using this IoT kind of a thing.
Yeah,
So I
yeah,
just
yeah,
wanted to
yeah,
know like how it is.
yeah.
yeah, that
I
he
am
will
telling you.
answer. Yeah, sir.
Yeah.
Tapan sir, please answer
So
that one, sir, because I don't know
yeah,
about.
yeah. So right. When we use RFID, RFID is only for the detection of an object, but we cannot detect the breast cancer using RFID. But using IoT, it can help to identify the breast cancer and manage it. How? Because when you study about the breast cancer and all, actually there are few muscles that actually it increase or it form in different or unordered way. So one is
Tapan sir, I think you are using two devices. One device you have to mute the
no,
mic.
no, no. I'm not using two devices.
Then some people, I think somebody else is
Yeah,
having two
someone
devices
else.
there. So
Right, right.
mic.
Someone else might be. Okay. So we can use one is the image processing, micro image processing device, and one is the tension device, with sensors which can identify the tension and pressure of muscles.
Okay.
You got the point?
Okay, sir. Yes, sir.
Yeah. And one more question is that any sensor available embedded in the textile which can wear? T. Suresh is he's asked some question like any sensor is available in the textile so that we can wear like that. Textile other than dust technology, we don't have any that much minimal sensor, I think. Correct, sir? Is that like any
No, the
sensor?
question
I
is
don't have.
no, I'm not getting the question itself.
Okay, okay,
What
I'll
you
read out
say?
the question. Is there any sensor available to embed in the textile which we can
In the
wear?
textile, okay, in textile. Yeah. There are few sensors available in textile. It's a microfiber. So there are
Okay.
few textile industry. They are actually designing a microfiber with the nanotechnology. The fiber itself is working as a sensor. So it can identify the stress of the people, stress level, then the temperature, then the one is galvanic characteristic of his skin. All this information are collecting from that nanofiber, nanotechnology fiber. Yes, it is available.
Okay. And then one
I
more
think
says
it
how
is
do,
done by one German company.
okay, sir. One more question is that how do sensor work in asthma?
Yeah.
Asthma.
So right. In case of asthma, how it can be implemented? Look, so when a person is suffering from asthma, so immediately he has to put more pressure on his lung. So if we can find out the tension, that is the contraction and expansion speed and the amount of the lung muscles, we can detect that he might be having the attack of asthma. This basically we have to identify, or we have to monitor the functionality of the lung.
Okay. So some people are asking about
Hello.
this.
So sorry for interrupting. This is Dr. Vaishali Dixit. So you
Yeah,
just mentioned about asthma. What I would like to ask is, does the person need to wear a device in this case?
yeah. It should be a wearable device. Yes, yes, ma'am.
Okay. And one for breast cancer, is it a implantable device?
Actually, it could be two type of device. One is implantable device, or it may be, say, if a person is study in this particular field in depth, they can design cloth. They can
Okay.
design the specific cloth which will be having the different type of sensor installed in the cloth itself.
Okay. But then that would measure the, can it pick up whether there is a tumor or,
Yeah,
and
yeah,
whether there is a
it can
tumor,
be,
it can? Oh, that's
yeah,
very
it
nice.
can be, because it can be reason, because say we have to design the system, we have to design that type of accurate sensors, and it is possible, and
But
many
then, sir,
people
one,
are working. Yeah, ma'am.
yeah, no, so please complete. You were
Yeah,
saying many people are
actually,
working.
many people are working in this particular field to identify this type of nano sensors, which
Okay.
will be
Sir,
implemented inside.
okay. In that case, a change of weight in of the person, would that not, give to false negative or false positive results?
Actually, the entire things will be connected to a data analytical center.
Mm-hmm.
So where artificial intelligence and data analysis has to be done. If
Okay. Hmm.
say the shape and the tenderness is changing in an abnormal way,
Okay.
so in that case, they can predict that that particular person might be having or might be suffering from a specific type of disease.
Okay, sir. So this
So
is
it will
very good
basically,
information.
Dixit, ma'am. Dixit, ma'am.
basically the sensor is responsible for collecting the different information, but it cannot process. Sensor cannot process. So ultimately, the decision making has to be done by the programmer, or that is the data analytical person.
Okay. Thank you, sir.
Dixit, ma'am, if possible, you just ping me this Madhivanan system administrator. I'll share you some link which their paper IEEE papers are there based on this one.
Okay,
Respiratory
sir.
monitors for asthma patient
Oh,
based on IoT, and we
okay,
have
sir.
some Intel ongoing projects, even
Uh-huh.
ready-made projects. Not ready-made project. There is some projects which is IDC classifier, which is
Oh,
used to detect the breast cancer and all. So I'll
Okay,
just
sir.
share you the link. Just able to ping
Yes,
me in
sir.
the WhatsApp.
Yes, sir. Thank
Thank
you
you so
so
much.
much, sir.
Sir, I think we'll close the session for now. So,
Okay.
some this chat logs, no? You received any chat log yesterday, sir, for the yesterday session and all?
No, I have not. I have not get. I think yesterday chat log.
Okay, okay, sir. I already forwarded to Arul, sir. He will. I'll just remember me again, so that this one, what to say, like he will again forward you again once.
Okay. Fine.
Okay, sir.
Thank you.
Thank you, Tapan, sir. So participants will disconnect this session, and next section will start as per the schedule by 11:30. Thank you.